Welcome to the online video lecture series on electromagnetic waves. In this session, we are going to discuss about skin effect and where we are going to discuss about depth of penetration. Okay, and we will also discuss about Poynting vector. Now, assume there is a metal. Okay, this aluminium is nothing but a metal. If an electromagnetic wave just passing in the free space, since the free space is having lesser attenuation, with much loss it will propagate. Okay, beautifully it propagates. But once it touches the metal, immediately it will convert into current, which means your electromagnetic wave will convert it as a current. There is a loss or death of your wave. Then my question is, will it not enter or penetrate into the metal? Yes, it will do penetrate. How much it can penetrate? It will penetrate, keep on, but as it penetrates inside the metal, the loss factor will be more, which means conversion of a wave into a current, that is metal current, will be more. So we call that as a depth of penetration. Or assume that I am having a metal object here. Okay, try to remember there is a metal object, metal, a iron piece, and defined that it is in the z-axis and the starting point is nothing but z is equal to 0. Now let us assume there is some electromagnetic wave just going like this. As long as it is in the free space, let us assume that it is much loss. Without any much loss, it goes in the free space. But once it touches the metal, what happened is the question. Now let us try to discuss. This particular title is nothing but skin effect. Okay, what is that particular skin effect? Our depth of penetration will discuss. Okay. Now, the electric field component solution E is nothing but Ex naught e power minus alpha z into cos omega t minus beta z is nothing but solution of the wave equation which we discussed. You should know that. Now, you also know current density inside a metal, what is created, is purely depends on your conductivity of the metal, and it also depends on the electric field what it is incident. So, the current created inside the metal is due to the strength of the electric field as well as its conductivity. If the wave strength is more, current creation is also more. If conductivity is more, again current creation is also more. Then if you try to substitute, is sigma Ex naught e power minus, since you told it is for a metal, since it is a good conductor, you should know alpha is nothing but root of pi f mu sigma into z. Sir, how come, sir? This we learned in the previous derivation, that is for the good conductor, am I right? Into cos omega t minus root of alpha beta both are same, which is pi f mu sigma z. Okay, so this is the modified equation which you are having. Now, your loss factor is alpha is here. Try to define. Now, my question here is, if the wave touches the metal, carefully listen, if the wave touches this particular metal, where at z equal to 0, that is starting point of the z axis, if z is equal to 0, that is just touching the metal surface, not penetrated, just touching. If you say z is equal to 0, the whole term is 0, then you define e power 0 is nothing but 1, okay, which means this whole term will be 1, and based on the conductivity your current will be created. That story is it. If z is equal to 1 by root of pi f mu sigma, what is this number? Based on this number I created. Now z is equal to some value here, z is equal to some value here. Now the wave started penetrating inside this metal. At one particular point when it reaches z is equal to 1 by root of pi f mu sigma. What is the distance? Some distance, some depth. If it penetrates that much distance, if it penetrates this much distance, try to substitute z value here. What is 1 divided by root of pi f mu sigma? It will get cancelled. So this term and this term will get cancelled. The result will be e power minus 1. Am I right? E power minus 1 in the calculator, if I do 0.368, which means 36.8 percentage more than this value, which means 36.8 percentage of loss will occur at this particular point. Now we define the distance what you have traveled. Please recall, z value equal to 1 by root of pi f mu sigma. The distance what you have traveled is nothing but depth of penetration delta. So the depth of penetration, this much distance will cause 36.8 percentage of loss. If it is more, 45 percentage, 50. Just I want to define there is a loss, that's all. Okay. Now try to write down. The amplitude of the wave propagates. The amplitude of the wave propagates in a conductor. The strength of the wave propagates in a conductor. I am repeating. The amplitude of the wave propagates in a conductor decreases by 36.8 percentage for a distance delta equal to z equal to 1 by root of pi f mu sigma is known as skin depth or depth of penetration. Write as a paragraph. The depth is measure of the depth to which an electromagnetic wave can penetrate into a conducting medium. Full stop. The phenomenon by which the field in a conducting medium, decreases rapidly because it's reducing 36%, it reduced for that much distance. Decreases rapidly is called skin effect. Just make a note. When a signal propagates inside a metal wire, it is a combination of voltage and current. And how much power of that particular signal, just multiplying it is just a scalar, so P, the unit is nothing but watts. So you should know volt into ampere results in watts. Sir, if the same signal is now propagating in a free space, I can call it as a signal or I can also call it as a wave. That the wave is not having voltage and current, his friend in free space is nothing but electric field intensity. For current it is magnetic field intensity. So recall my dear, the product of voltage and current is the power. Here also the product of electric field and magnetic field has to be the power, no doubt. But the beauty, since it is both are vector and the power also propagate in the x direction, so it is a vector. It cannot be dot product, it should be the cross product. Why? Because cross product is between two vectors, result is also a vector. Now I can call this as a P, I can also call this as a S, nothing wrong. And you should know volt per meter is the unit, ampere per meter is the unit, volt into ampere will give you watts, denominator will result in the meter square. So the power in a metal is P, the power in the free space is nothing but S. This is power is watts, which is a scalar, this power is a vector, which is watts per meter square. Keep this in a mind. Now we try to derive the result for E cross H, nothing else. I am going to do a beautiful derivation. Many question paper it is that. So aim is to find E cross H, nothing more than that. Very important derivation. Take down electromagnetic wave power. Electromagnetic wave power in free space can be defined in terms of cross product of electric field intensity E and magnetic field intensity H as a Poynting vector P equal to S arrow equal to E cross H. Just write out. It was defined by John H. Poynting, which is a scientist. So we can call it as a power vector, or we can also call it as a Poynting vector. Okay, it's a scientist named John H. Poynting. Okay, don't think about the cricketer Poynting. It is the scientist John H. Poynting. Just keep it in mind. Now my aim is to derive E cross H. Okay, and we know from the vector identity, del dot A cross B. Remember, my dear, both are vector. Is nothing but B dot del cross A minus A dot del cross B, which is a known vector identity which we have defined in the beginning of the syllabus. Why can't I replace A and B as E and H? We can do, nothing wrong about that. Then del dot E cross H, all are vectors, I don't want to waste the time here, is equal to H dot del cross E minus E dot del cross H. We know this is the modified vector identity for your electric field as well as the magnetic field. Now you should know our aim E cross H is available here. Okay, our aim is to bring this E cross H by removing this del with some techniques. And what is our Maxwell's equation? We know what is the Maxwell's equation here. We call Maxwell's equation del cross E equal to minus dou V by dou T. Another Maxwell's equation del cross H is equal to J plus dou D by dou T. On substituting, we have del dot E cross H equal to H dot minus dou B by dou T minus E dot J plus dou D by dou T. And now some more substitutions we are going to do. For free space, you should know B is equal to mu naught H, D equal to epsilon naught E, and J is nothing but sigma E in case if there is a metal, if it is affecting a metal. Then your del dot E cross H can be written as H dot minus mu naught dou H by dou T minus E sigma E minus, I just splitting into two, minus E epsilon naught dou E by dou T. Okay, E I multiplied inside, minus E here, minus E here. J is nothing but sigma E, another dou D by dou T is nothing but dou E by dou T. Okay, a slight modifications we did. Now some more changes I am going to do. Before that, in this place minus, here also minus, here also minus. If you take all minus this side, the result will be minus del dot E cross H will be sigma E square, this particular term, E dot E nothing but E square, plus epsilon naught E dou E by dou T, okay, epsilon naught E dou E by dou T, plus mu naught H dou H by dou T. Okay, first term, second term, this is the third term. Now for the general mathematics, you should know dou by dou T of E square. Okay, just remember it's a partial differentiation. It's not differentiating with respect to E, differentiating with respect to time will result in 2E dou E by dou T. Okay, dou by dou T of E square is equal to 2E dou E by dou T. Then from here let us try to modify. What is dou E by dou T? Is nothing but a dou E square divided by dou T into 1 by 2E. Am I right? Same is applicable for even H also. Now let us replace dou E by dou T by that particular term minus del square E cross H sigma E square plus, if you try to substitute epsilon naught divided by 2, recall dou E by dou T, if you replace 1 by 2E, E will get cancelled 1 by 2, that is nothing but epsilon by 2, dou E square by dou T plus, same if you do here also, mu naught divided by 2 dou H square by dou T. Okay. Next you can just take some terms common. Now I am going to do one more work. Integrate everywhere for volume. Integrate everywhere for volume. The result will be minus integration del dot E cross H dV. Okay. Integrating for volume. Integration for volume sigma E square dV plus, since dou by dou T is common for these two, dou by dou T it is for the volume integration, it is for x, y, z. It is independent of time, so dou by dou T I brought outside. Epsilon naught E square by 2 plus mu naught H square by 2. Sir, why you did like this? Half mv square. Half mv square. It's an energy formula dV. Okay. And now I am going to do some small modification. From divergence theorem, closed integral d dot ds is equal to volume integration del dot dd. Okay, is the general formula which converts volume to surface, and it will also convert del dot d to d. Del dot E cross H can be converted to E cross H. This is a technique to remove this del dot, because my aim is to find E cross H. That's what I am doing. From divergence theorem, just make note. From divergence theorem, we have minus closed integral. Okay, this particular term is converted. Okay, this is the volume. This left hand side is now converted as E cross H dot ds. Okay, this whole thing is converted here. Is nothing but left hand side is converted volume to surface. That's all. Right hand side is remain same. A volume integration sigma E square dV plus dou by dou T of volume integration epsilon naught E square by 2 half mv square plus mu naught H square by 2, the same formula dV. Okay, so just try to copy down this particular equation carefully. After this, we will like to discuss what is this particular equation. Just to take a football. Imagine there is some sort of a hexagon shape here with the stitchings. Inside the football, you will be having air because there is a bladder. Okay. Imagine you remove that bladder. Okay, there is no bladder. Outside skin, that is a hexagonal shape with some stitching. Now, try to pour the water inside the football through that small hole. What happens? The water will get filled in that particular football, as well as there will be some leakage component in the hexagon because it is stitching. Even though tight stitching, now it will be the leakage because there is no bladder. Three terms I am going to define. Water entering inside the football. What is a football? Closed surface which has a volume. Water entering inside the football. Water stored in the football. Leakage. Three terms, carefully listen. Water entering inside the football. Water stored inside, second term. Leakage. Now recall, the football is nothing but the room. Okay, the football is nothing but the room. Now you are inside that particular room. Who is the surface? This wall is the surface. You may have a windows, you may have a glass doors and everything. Water entering inside the football. Electromagnetic wave enter inside the room. There is a leakage in the surface. On your walls you will have some loss of that electromagnetic wave. Water stored in the football. I can receive the signal in the mobile phone. So just recall, if I am using some mobile phone inside my room, it is because the electromagnetic wave enter inside my room and there is some loss in this particular wall, as well as I will get some signal. So three terms. What are the first term? The electromagnetic wave energy, which is a power, enter inside the closed surface, which will have water stored, electromagnetic wave stored inside the volume. Am I right? Dou E square by dou T H square. That is nothing but the energy stored in terms of electric field, energy stored in terms of magnetic field inside the volume. And as time progresses, that will start a decay, reduce. Dou by dou T, as the time it will start reduce. As well as sigma E square is nothing but loss in that particular conductivity. Okay, please do remember. In case if you have beautiful metal throughout that particular wall, then conductivity will be more, loss will be more. If you have room is full of concrete wall or even just a glass, loss will be less. So now a superb concept we got. Whenever you are inside a metal case, signal won't enter inside because metal case is nothing but sigma, where the loss will be more, waves will not penetrate. So you do this reverse. Take a metal box, keep your mobile phone inside and close that particular metal. Definitely the signal won't propagate. If you try to call that particular mobile phone, after 2 or 3 minutes you will come to know signal not reachable. Reason, the wave enter inside that particular box. Since it's the metal, that sigma conductivity is more, everything become lost. There will be no energy stored inside. Please remember. Take a wooden box or take a concrete wall, definitely the signal will enter. Now below this you try to write down. Left hand side, LHS. LHS indicates power entered inside closed surface of a volume. Next, first term of the RHS indicates, right hand side, okay. First term of the RHS indicates loss of power due to metallic conductor. Second term of RHS indicates energy stored of electromagnetic waves inside the volume and it decays with respect to time. Okay. So with this I would like to conclude this particular session. Even in examination when you write this also you should write that first term, second term and other terms. Okay. With this I would like to conclude this particular session. In the next session we will discuss some problems on this particular conductivity, skin effect, everything. Thank you.